Hello viewers, Moments question 1, and we have a seesaw with two weights at each end. Each weight is a 50 kilogram mass, and each weight is 2 meters away from the pivot of the seesaw. So we need to find out whether the situation is balanced. The weight on the right hand end is going to act to cause the whole seesaw to rotate clockwise, whereas the weight on the left hand end is going to act to make it rotate anti-clockwise. And if the situation is balanced, then there will be no tendency for it to rotate either clockwise or anti-clockwise. We need to use moments to prove whether that situation is balanced. So we're going to take, for the purpose of this question, clockwise to be positive, which means we're going to have the weight at the right hand end acting in the positive direction and the weight at the left hand end acting in the negative direction. So the right hand end is going to be positive and the left hand end is going to be negative. So at the right hand end, the weight is 50 times 9.81, and we need to multiply by its distance. Perpendicular distance here is 2 meters, and at the left hand end we've got also a weight of 50 times 9.81 newtons, and its weight and its distance is 2 meters. So this is going to be equal to 50 times 9.81 times 2, which is 981 minus 981 as well, gives you 0. So the moment is 0, which tells us that it's balanced. So it's balanced, it's in equilibrium, as the sum of moments is 0 there. Now, what about question B? We've now got a 200 kilogram mass on that right hand end, so it's going to be the clockwise moment is 200 times 9.81 times its distance is 2 meters, and from the left hand end acting anti-clockwise we've still got 50 times 9.81 times 2, so this is 3,924 Newton meters is the moment, minus here we've got 981, and if we calculate that we get 2,900, and what do we end up with there? We end up with 2,943 Newton meters, which is not 0. We're getting a positive answer, which means that there is a tendency for the whole system to rotate clockwise, and therefore it is not balanced. Not balanced, and it rotates clockwise. Okay, so quick part B was not balanced. But for part C, we need to find, is there anywhere the 200 kilogram weight can go in order to balance the seesaw? So we're looking for, if it is going to balance, we want to know where it is going to go, which is probably not at the 2 meter mark, assuming that the distance from the 50 kilogram weight to the pivot is still 2 meters. We would need to move the 200 kilogram mass somewhere else if indeed we are going to get the system balanced. So we are going to have the weight on the right hand end, which is still going to act to make the thing rotate clockwise, is 200 times 9.81 multiplied by some unknown distance, minus, we're not doing anything to the left hand end of the seesaw, so its weight and therefore its moment, because its distance is going to be the same, is unchanged. So that's going to be 50 times 9.81 times 2, and we want it balanced, so we want the whole thing to be equal to 0. So therefore, if we move this whole term to the other side, which is 50 times 9.81 times 2, and on this side we've got 200 times 9.81 times our unknown distance. Now, the 9.81 multiplying is common to both sides, so we can divide the whole equation through by 9.81, and if we do that we get 200d equals 100, because we're left with 50 times 2 on that right hand end, so d is therefore 100 over 200, which works out to be 0.5 metres. So while situation B here is, as it stands, not balanced, if we bring in that 200 kilogram weight so that it's only a distance of 0.5 metres from the pivot, then we will have a situation of balance. Okay, thanks for watching. Over and out.